Okay, number 1. Anytime you're given a trinomial that is in the form ax squared plus bx plus c and the a value equals 1, you can factor it using the bubble method, is what we call it. Isn't this in the form ax squared plus bx plus c? They just chose to use the variable b instead of x. And isn't your a value a 1? So that means we can factor it using the method. And if you forget how to do this, you do have a graphic organizer on the previous page that shows you when you're dealing with a trinomial with an a value of 1, use the bubble method. That's where you look for two numbers that multiply to your c value, and those same two numbers have to add up to the b value. And then you just put them in binomials. Okay, so you can always start by just drawing your two binomials, your sets of parentheses. Now obviously, if you were to FOIL this, you start with f, which is first, which is this term and this term. To get b squared, what has to be at the beginning of each one? Right, because b times b is b squared. Now like the graphic organizer said, you're looking for two numbers that multiply to c and add up to b. Well, what is our c value for this one? 7. So what are some numbers that multiply to 7? Okay, and it's prime, so those are the only numbers. Do those numbers also add up to 8? Yes. And both of them need to be positive, so you put a positive 1 and a positive 7. Would it have been okay if I'd have written b plus 7 first and then b plus 1? Yes. Now, you don't have to write this, just watch. I'm going to show you why this is the answer. If I quickly FOIL, b times b is b squared. b times 7 is 7b. 1 times b is 1b, and 1 times 7 is 7. And then don't these two middles combine to ab, which brings you back to your question? That means we have the right factors, because when I FOILed them, it went right back to the answer. Okay, so let's look at number 2. This time, we're dealing with a trinomial again, and it has an a value of 1. So we're going to factor it the same way, the bubble method. Okay, what variable do we need at the beginning of each one? An n, to make that n squared. And then this time we're looking for two numbers that multiply to give you 10. And the same two numbers have to add to give you a, right. Okay, what are some factors of 10? Okay. You think you can get an 11 with a 2 and a 5? So let's go to some different numbers. What are other factors of 10? Okay, do you think you can get an 11 out of those? But for them to multiply to a positive 10 and at the same time add to a negative 11, what do you need to do about signs? If you make them both negative, they'll still multiply to a positive 10 because a negative times a negative is positive. But once you do that, they'll also add up to a negative 11. So your factors are n minus 1, n minus 10. Alright, number 3. What goes at the beginning of each binomial? M. And this time we're looking for numbers that multiply to give you a negative 90, because that's your c value. And those same two numbers have to add to give you a 1. Isn't there an understood 1 in the b place? Okay, so what are some numbers that multiply to 90? Okay, do you think you can get a 1 from a 9 and a 10?
Yes.
Okay, if we do negative 9 times 10, that is negative 90, and is negative 9 plus 10 a positive 1? Yes, so we need a negative 9 and a positive 10. Okay, you go ahead and try 4. At the beginning of each binomial, you need n, right, to make that n squared. And what numbers did you find that will multiply to a negative 12 but add to a positive 4? 6 and negative 2. Because 6 minus 2 is 4, and 6 times negative 2 is negative 12. Alright, number 5. Go ahead and try 5 and 6. Alright, for number 5, what factors did you get? N, okay, so let's see if that works. A negative 9 plus a negative 1 does add up to a negative 10. And when you multiply a negative 9 and a negative 1, you get a positive 9. Good. Now remember, it's okay if you put your n minus 1 on this side and n minus 9 on that side. Okay, number 6, what'd y'all get? Right. Now, and sometimes, like on a test, you may see this written like this. B plus A squared, since they're the same factor. Okay, now, like I said earlier, every problem we've worked so far has been in this form, and every single one of them had an A value of 1. There was always a 1 as the leading coefficient, right? Now I want you to flip to the next page. Okay, y'all are going to have to tell me because it cut mine off. What does number 13 say? Yeah. Plus 8? Okay, so let's go ahead and try that one. Isn't that the same as the ones we've been working? It's in ax squared plus bx plus c form, and the leading coefficient is 1. So we're looking for two numbers that do what? Right, and we can go and put our b in each one. What numbers will do that? What kind of 4 and 2? Negative 4 and negative 2, right? Because to get a positive 8, your signs have to match. You either have to do a positive times a positive or a negative times a negative. But for them to add up to a negative, they both need to be negative. Okay, number 14. What does number 14 say? Okay, so this time we need an n at the front of each one. And what numbers multiply to 8 but add to 6? 4 and 2. Okay, number 15. How is number 15 different? Right, it has a 2 in the front. It no longer has an A value of 1. So we're going to have to factor it by GCF. If you look back at your little graphic organizer, it'll say, you know, when A doesn't equal 1, you check, is A the GCF? Okay, so with this problem that we're working on, is 2, which is in the A place, a GCF of 2, 6, and 108? Yes. So we're going to factor it out. It says that if it's a GCF, you can factor it out and then use the bubble method. Okay? So if 2 is the GCF, you take it outside the parentheses. Now, basically what you're doing is you're undistributing the 2. So when you undistribute 2 from 2n squared, what's left? Just the n squared. When you undistribute a 2 from a 6n, what's left? 3n. Because think about it. Isn't 2 times 3n 6n? And then bring down the minus. 2 times what is 108? 54. Now, for those of you who have trouble with what I just did, you could also think about it like this. Once you decide what your GCF is, you just divide it out of all of them. Okay? 2n squared divided by 2 is just 1n squared. 6n divided by 2 is 3n. Negative 108 divided by 2 is negative 54. That's another way to look at it. Okay, so now that we've taken out that 2, don't we have something that we can factor by bubble method like the previous page? So to get n squared, we need n times n. And now we're looking for two numbers that do what? Multiply to give you negative 54 and add to give you 3. Okay, 9 and 6 will multiply to 54, but how are you going to get a 3 out of a 9 and a 6? 9 minus 6. So a 9 and a negative 6 are 3, and a 9 and a negative 6 multiply to negative 54. So positive 9 and negative 6. This has to be part of your final answer. You have to continue bringing it down. Okay, so let's look at number 16. We have an A value, and that A value is not a 1. Is it a GCF? Can you pull 5 out of all 3 of those terms? Yes. So go ahead and write 5 on the outside of the parenthesis. And now remember, like I said, if you're not good at just thinking like undistribute, all that's basically going on is you're dividing it. So what's 5n squared divided by 5? 1n squared. And you don't have to write the 1. What's 10n divided by 5? Positive 2n. And then what's positive 20 divided by 5? Positive 4. So now we're looking at a trinomial that we can factor using the bubble method. So you're looking for two numbers that do what? Multiply to 4, because you always multiply to get the last number and add to get the b value, which is 2. Are there any numbers that will do that? No, because think about it. The only way to get a 4 is a 2 times 2, and 2 plus 2 is not 2, or 1 times 4, and that's not going to give you a 2. So that's the final answer. It can't be factored further. Okay, why don't y'all go ahead and try 17 and 18. Okay, let's go and look at it. With number 17, you have a trinomial that's in ax squared plus bx plus c form, but the a is not a 1, it's a 2. Is 2 a GCF of all three of those terms? Can it be pulled out of all of them evenly? Yes. So when you pull out a 2, what's 2k squared divided by 2? 1k squared. And then bring down the plus. What's 22k divided by 2? And then bring down the plus. What's 60 divided by 2? Okay, so now that we've pulled out the 2, we're now dealing with a trinomial that has an a value of 1. So we can do the bubble method by looking for two numbers that do what? Okay, and what numbers will do that? Right. 5 times 6 is 30, and 5 plus 6 is 11. All right, number 18, we're back to a trinomial with a leading coefficient of 1. So we don't have to worry about a GCF. We can go straight into the bubble method by looking for two numbers that do what? Right. What numbers will do that? Okay, but to get a negative 90, negative 10, okay, because negative 10 plus 9 is a negative 1, and that's a negative 1 in the b place. But when you multiply them, you get a negative 90. All right, number 19. This is another one with an a value of 1, so we don't have to worry about a GCF. We can just go right into factoring. But this time it's set equal to 0, and we'll talk about what that means in a second. First, just factor it like normal. X times x, and then what numbers multiply to 12 and add to 7? 3 and 4, or 4 and 3, however you want to write it. Now, anytime it's set equal to 0, they want you to actually continue and solve. They don't want you to just stop there. They want you to take each of these factors, and they want you to set each of them to 0. Okay, anytime it's set equal to 0, they want you to factor and solve, which means take your two factors and set them both equal to 0. Now to solve it, how do we solve this one for x? Subtract 3 on both sides, right? So what will your answer be for this one? Right? And then for this one, what would we do to both sides? Subtract 4. So we would end up with x equals negative 4. Now let's talk about why those are the solutions to this trinomial. If I rewrite this, x squared plus 7x plus 12 equals 0. But in the x places, I left blanks because I'm going to plug in one of my x values. Type that in and see if it really equals 0. Okay, does it equal 0 when you plug in a negative 3 for both x's? Okay, now plug in a negative 4 for both of them and see if it also produces a 0. Did it give you a 0? So that's why those are the solutions, because when plugged in, they make the equation equal 0. Okay, go ahead and try 20 and 21. Alright, number 20. Were you able to factor out the 5? Okay, when you did, what was left? Right? Because 5 times v squared is 5v squared. 5 times negative 6v is negative 30v, and 5 times 8 is 40. And now, can that be factored further? Are there two numbers that multiply to 8 and add to negative 6? Okay, what are they? Right, negative 4 and negative 2. Alright, and then number 21, what would you have done first? Factor out 2, and then what does that leave? Okay, so that's like a p squared plus 1p minus 2. Can that be factored further? Are there two numbers that multiply to a negative 2 and add to a positive 1? What numbers will do that? Right. 2 and negative 1 add up to positive 1, and when you multiply them, you get a negative 2. Okay, now go ahead and turn to page 8. Okay, now we're moving into graphing these, which we probably won't get to today, but that's what we're moving into. That's why we've been reviewing how to factor. So, this is just like we've been doing, except for it's set equal to 0. So we're not only just going to factor, we're going to solve for x. So, since it's a trinomial with an a value of 1, I factor using the bubble method. Okay, to get that x squared means you have to have an x in each one. And then what two numbers will multiply to negative 4 and add to positive 3? Right. A positive 4 and a negative 1. 4 times negative 1 is negative 4, and 4 plus negative 1 is positive 3. But like I said, since it's set equal to 0, we have to continue. We have to set each of the factors to 0. Okay, now to solve for x, what do I do? Subtract 4 on both sides, and so this x will equal negative 4. And then to solve this one for x, what do I do on both sides? And so x equals 1. Those are the solutions. They're also called zeros or roots. Okay, so you can hear any of those words. If they ask for the solutions, the zeros, or the roots, they're asking for those. Now, why is it that those are the solutions? What makes those the solutions? What did we do a while ago to show that those are the solutions? Right, like if I plug in a negative 4 right here and a negative 4 right here, negative 4 squared is positive 16. 3 times negative 4 is negative 12, and then if I bring up that minus 4, is 16 minus 12 minus 4 equal to 0? Yes. And if I plugged in a 1 in both of the x's, 1 squared is 1, 3 times 1 is 3, and then minus 4. So is 1 plus 3 minus 4 equal to 0? Yes, that's why those are the solutions, because they make the trinomial equal 0. Okay, now I'll turn to the next page. I want you to try 1, 2, 3 at the top. Okay, all three of them have an a value of 1. So none of them have to be GCF. We can go straight to the bubble method. If by looking for two numbers that multiply to 6 and add a -7, and what two numbers do that? Okay, but then since it's set equal to 0, they want you to also solve. All we've done is factor. To solve, you set each individual factor to 0, and then you just solve. So to solve this one for x, what do? Add 6 to both sides, and so adding 6 to that will give you 6, right? And to solve this one for x, what do you do to both sides? Add 1, which will give you 1. Basically, doesn't the sign just change? Okay, for number 2, what numbers multiply to 6 and add to -5? -3 and -2. So when you set each of them to 0, what are you going to end up with for your final solutions? Correct. And why is it that these are the solutions? Right. If I plug 3 into both of those x's, it'll produce a 0. If I plug 2 into both of those, it'll produce a 0. Okay, number 3. We're looking for two numbers that do what? Okay, and what two numbers do that? And so when you set them to 0 and solve, what are you going to end up with? Right. Okay. These solutions are also where the graph will cross the x-axis. Okay, so like if we were to graph that, you would see the graph cross the x-axis at 1 and 6. Okay, for the remainder of class, I want you to finish up page 6 and 7, the problems we didn't do together.